Welcome to the 7th video in my FPS character controller tutorial series playlist. The full playlist as well as the GitHub source code will be linked in the description. In today's video, I'm going to show a couple simple ideas to create interactable components in your games. So here I've got this very basic button model that I made in Blender with a push animation on it. And if you want to follow along with this tutorial, I'll link this very simple model in the description. And I'm going to place it next to this doorway, and I'm going to make it into the child of a static body. And essentially what we're going to do is we're going to send a shapecast, which is similar to a raycast, and we're just going to essentially check in front of the player and see if the player is looking at this button, and that way we'll know if they can press it or not. Because obviously we only want them to press it if they're like in range of the button. And so to start off here, I'm going to right click the button, and it's a GLB model scene. So you can right click make local, and that'll kind of separate all of its components. So I'm going to use that gray base cylinder as the collision shape for it. So I'll select that. Then what we can do is click on this mesh tab at the top, and that gives us some options to easily make collision shapes out of it. So for this one, I'm going to use the fourth one down there, create simplified convex collision sibling. Then if I just drag that down to the static body 3D, that creates a perfectly shaped collision shape for us. And so now we have a collision shape for this button, and to get the player actually interacting with it, one thing you can do is add a raycast or a shapecast to your character. Now you could add a raycast for this, but there's another node called a shapecast, which I think offers a bit more flexibility. A raycast basically only shoots an extremely thin laser beam type thing towards the interactable, so if you have a really small interactable or item, it's going to be extremely hard to press. So instead, I'm going to add a shapecast 3D node to my camera 3D, and I'm adding it to the camera 3D because I want it to shoot directly towards where the player's looking, so forward and relative to the camera, and I'm adding a sphere shape to it. And this can function basically exactly the same as a raycast, but it offers the added benefit that you can control the width and shape of the object. So I'm setting the target position pointing directly ahead, and I'll set the sphere's radius to 0.25. And so it's going to shoot a sphere directly ahead, and this is going to be a lot more forgiving. Like if you're a millimeter off, it's still going to press whatever you want. And so yeah, the concept of a shapecast I think is pretty simple here. It starts at the start position, whatever the default transform of the shapecast is, and then it's going to shoot whatever shape object that you choose in kind of like a ray out forward from the character, but it's going to be in the shape of whatever shape you choose. You can also just set it at 0, 0, 0, for instance, if you just want to check like against one sphere. This is kind of useful sometimes, like say you want to get a sphere around your character, and then you can just put a shapecast targeted at 0, 0, 0, and then maybe like increase the size of the sphere for an area around your character. And these are a useful thing to use in Godot. And a couple settings to pay attention to here. Choose what it collides with. Maybe you also want areas, because sometimes interactables, maybe that's just like an area and it's not actually a physical static body or anything. And also pay attention to what collision masks it's interacting with, and make sure whatever object you want to interact with, the mask is selected in your shapecast 3D as well. And now I'm going to leave my mask on 1 because that's the layer all my walls and my level are on, and all like the physical objects in my game. And I don't want players to be able to use objects through walls. Like if like an item, secret item is on the other side of a wall, I don't want them to just be able to shoot their raycast through the wall and pick it up essentially. So I'm leaving mine on 1, so it just collides with everything normally. And I'm going to set the max results here to 2. And this is basically going to stop once it hits this many objects, so like a wall. And the reason we're setting it to 2 is because the first one is likely going to be the player, and we're going to check this in code. Now there is this exclude parent option, but if your setup is like mine, where your shapecast is not a direct descendant of the character body 3D and it's maybe nested in multiple nodes here, this is not going to work. So I'm just going to set it to 2, and then we'll just check in code if the first collision was the character body 3D, and then we can just discard it. And to define what the shapecast can actually interact with, we are going to use something called the component pattern. So I'm going to create a new script here that just inherits the regular node, not 2D or 3D, but just regular node. And I'm going to call it InteractableComponent.gd. And this is going to be a very basic script that we can use to basically mark any object in our scene as interactable. So I'm going to give it the class name InteractableComponent. And when you give something a class name like this, it allows you to easily add it as a child to any scene you have. So if you click Add Child Node after you created that script, it'll show up in your Create New Node menu. And then I'm just going to add it to my button's static body. And now this is probably a pretty common pattern you'll see used in Godot code bases. In a game engine like Unity, what you could do is just throw multiple scripts on the same object to give it different behaviors. But in Godot, you can only have one script per object. So an easy way to replicate the same effect is just to have these component node children. This node will serve as an easy way to check if a given parent implements this interactable type or has this interactable trait. And we can just check if that parent node has an interactable component child, and if so, it's interactable. And then also we can use it to encapsulate a small core of reusable code that all interactables will use. This is all the code the interactable component needs for now. It just defines a signal interacted, and then we're going to emit the interacted signal once we interact with it and call this function from the player. And now back to my FPS character controller script and scene here. I'm going to do a couple things. First, I'm going to rename this shapecast to Interact Shapecast 3D and right click Access as Unique Name so we can easily access encode by that name. And then I'm going to add a keybind for interacting with objects. I'm going to call my action interact, and then I'm going to bind it to the E key. And then I'm also going to bind mine to the X key on my gamepad controller. And then so now back in the code here, I am going to define a function called getInteractableComponent at shapecast. And here we're just going to iterate over all the collisions in the shapecast. And like I said before, we are going to make sure it's not colliding with the player with this line. So we're checking if the first collider is not equal to money dot. And what is money dot? If we drag the character body 3D in, you'll see it's shorthand for the current base of the scene, which is the character body. And so that part just allows us to not count the first node hit if it was the character body itself. And for this next part, here's where the interactable component comes in. And so you can see the easy way to check if an object, so we're getting the object we collided with, and we're checking this get node or null interactable component, and that returns the interactable component, which is a direct child of the node that was collided with. And we're both double checking it is indeed an interactable component and making sure it's not null with that is part at the end. And so yeah, if this check passes, we know that the object that the shapecast collided with is interactable because it has this component that we put on it. And then so we will just return the interactable component on that collider. And we only set the max results on the shapecast to 2, so if neither of those two contained an interactable component child, then we didn't find anything interactable and we just return null from this function. And now we've defined the function we need, so now I'll use it in the process function, and every frame I'm going to see if there is a interactable component at the shapecast right in front of us. And if there is, I'll also check if the player is attempting to interact by pressing the interact button. And if both of those are true, I'm just going to call the function we defined earlier on that interactable component that the shapecast found, and I'm going to call interact with. And that is enough to get our player triggering interactables. But if you remember, our interact strip was pretty bare bones. We don't actually have it hooked up to anything right now. It's just this like empty wrapper that has this interacted signal that we're not actually using for anything. So let's make it do something. So my button model I imported has this button press animation on it that I made in Blender. And now if you right click in the node signals tab, you can connect the interacted signal to whatever you want. And it's pretty flexible. You'll see I'm going to select this animation player node in this whole list of nodes that I can connect to. And if you click unclick script methods only or compatible methods only, you're going to get this whole list of methods that you can trigger using that signal. And this is going to give you access to pretty much any function on whatever node that you have selected. So whenever this event is triggered, we can call any function on any other node just by connecting the signal to that function. And so in this case, I'm going to use the animation player's play function. And I'll play that button press animation. And after you've selected a receiver method, if you click on the advanced checkbox, you're going to get a whole lot of options here, and you can actually define the arguments that you want to pass into the function. So in this case, the first argument that the play function takes is the animation name, so I'm going to make it button press and click to connect that signal. And now if I give that a try, you'll see that is enough to get a basic interactable component feature working. So if we walk up to this button, the shapecast is going to detect it. We press E, and then it calls interact with, and then the signal gets sent over to start the animation. And that works, but I also want to have kind of a notifier that we're hovering the button, so I'm going to add some stuff to our interactable component. So I added this dictionary characters hovering to my interactable component. And the reason it's a dictionary is I'm not assuming there's only one player in the game. Maybe it's multiplayer. Trying to keep it as flexible as possible. And I'm going to add this hover cursor function, which kind of similar to interact. We're going to call this from the player, but not just when we're pressing it, anytime when we're looking at the interactable at all, we're going to call it. And when we look at it, I'm going to set the character key in the dictionary to the current process frame we're on. So in this way, I'll be able to keep track of whatever characters are currently looking at the interactable. And engine.getProcessFrames, that basically just saves whatever frame they last looked at it. And now I'm going to add this other function. Again, I'm trying to keep this as flexible as possible. So get character hovered by current camera. So in this function, we're going to loop through all the characters that are hovering it. And this variable right here, this is a way to get the current active camera if you didn't know. So we're getting the viewport we're drawing in, which is kind of like what Godot uses to render everything. And then we're going to get the active camera for that viewport. What relevance is the active camera? Well, we can assume if one of our players that we're tracking has the active camera as a child, then that is the local primary player. You can have many cameras on your scene, like for a multiplayer game, maybe every player has a camera, but only the local player's camera is active and rendering to the screen. And the find children with the asterisk, that recursively searches all children in the player's node tree, and we're looking for the camera 3D type, which is the second argument there. So if we find the current camera in one of the hovered characters that we're tracking, then we know the local player is actually hovering over the button and not just someone like on their team that happens to have a camera object on it. So then we can like draw a visual effect around the button, show like an outline or something if it's being hovered. Next, every process frame, I'm just going to keep track of the characters currently hovering. And if they're basically not hovering anymore, if the current frame is greater than one of the frame they last hovered, I'm just going to erase them from the list of characters hovering that we're tracking. And now I'll go over to the player script, and I'm going to call this new function in the process frame. So every frame we're hovering the object and we detect the component, the shapecast, I'm just going to call hover cursor to notify the interactable component that a player is hovering their cursor over it. And now within our interactable components, we are always going to know who is hovering over them. And we can use this piece of information to draw visual effects, for example. In this case, when the player hovers their cursor over the button, I want to draw like an outline notifier around it. And so if I go back over to my scene here, I am going to create a little visual effect on the button. And I'm just going to create a CSG cylinder 3D for this to surround this button shape. And I'm going to size it so it fits over the button. And then I'm going to add a material to it, and very simple way to get like kind of a cell shaded look. I'm going to turn it black, and then the two tabs you're going to want to look at are the shading and the transparency tab. In the shading, you can turn the shading to unshaded, and this will just make it kind of like a more cartoony black look. And then you can change the cull mode to front, which kind of gives it this like cell shaded look where you can only see the faces from outside in. And then finally, I'm going to rename it to Interact Outline. And I'll enable or disable this when the button is hovered. So to get that working, I'm just going to attach a script to the static body 3D, and I'm actually going to make it a built-in script, which means it doesn't show in the project files, which a lot of times that would be bad practice, but considering this is just going to be one line, I am just going to make it a built-in script, and it's built into the scene only, just to like save an extra file. And I'm going to set the interact outlines visible property to the interact component, and I'm going to use this get character hovered by camera function we created. So I'm going to set it to visible if the result of this is not null. And this exclamation point might look like magic if you haven't seen it. This is a habit of mine from using JavaScript. This is referred to as coercing a variable to a Boolean. It would work the same if you just did not equals null, but basically the exclamation point operator will negate whatever is in front of it, even if that's an object. So if it's a truthy value, being anything that's not 0, null, or false, then the exclamation point operator will make it become false. And then we put another exclamation point to make it true. So if it's a not null object, that's a fancy way of saying true. So set it to visible if it's not a null object. And remember this function we defined before where we can check if the local player's camera is hovering the interactable. And just to justify this get character hovered by cur camera function a little bit more, another use case I had in mind was like, what if it was a multiplayer game and the players were spectating each other? Then you would still want to show the hover outline even for a player spectating another player. So in that case, it wouldn't be the local player technically, but we would still want to draw like the hover outline on it. So I thought this was a flexible method to always know when to draw visual effects for hover. And now we have a way to display simple hover outlines on interactable objects or any other effects you would want to draw when the player hovers over an interactable. And now to showcase how this interactable component is pretty flexible and we can use it for just about anything now, I'm going to make a simple door. And I'm using the animatable body 3D, which is an inherited type from the static body 3D, but the difference is that it's going to properly push things as it's moved or animated. And then I'm adding a mesh instance 3D with a box for the door shape on it. And then with the animatable body 3D, I'm just going to position it, you'll see, right so the pivot point is going to be at the corner of this door frame. And then I am just going to shape it into the same shape as this doorway shape I got right here. And I'm also going to put a darker color on it to make it clear that it's a door. And now you'll see when I rotate this animatable body 3D node, it pivots around the origin and the mesh is offset, so it's going to pivot like a door hinge. And now the animatable body 3D still needs a collision shape, so I'm going to use that trick again with the mesh tab, and I'm going to create a simplified convex collision sibling again and use that as the animatable body 3D's collision shape. And now that we have that door, it'll be pretty easy to get it animating using an animation player node. You can animate just about any property that you see in the editor using an animation player node, so we'll animate the door's rotation. I'm going to add a new animation called open and add it to the animation player. When you have an animation selected on an animation player, you can then go and select any other node in your scene. And then you'll see a bunch of these keys next to all the properties. And then you can click a key and add a keyframe to the animation. This is going to save the object's position at that time and keyframe it, much like any other animation program if you ever used any other one. So I'm going to scroll to the 1 second point and then I'm going to rotate the door, and then I'll add a keyframe for that as well at the 1 second point. And then you'll see that when we scrub along the animation player, it interpolates between these values. And we could just call play directly from a signal like before, but I'm actually going to add a script to this door, and I'm going to make it a built-in script. Now for the code in the animatable body 3D, I'm going to have this export variable open, and it's going to be false by default. And then I'll define this update door function. If the door is currently marked as open from the variable, we're going to play the animation player open variable, or open animation. Otherwise, we are going to play backwards the open animation, which would be closing it. And then if the animation player is not currently active, we might have to set it to active, so I'll set active to true. And then where we're going to call this function is in somewhere called the setter. So you'll see this syntax in Godot, and this is useful to know. And basically, setters and getters as well allow you to always catch when a variable is being set or accessed. And this is basically like a foolproof way, like nothing is going to get past this. We're always going to know when this variable is getting changed. So this is going to be useful for a variety of things. In this case, we are going to check whenever the open variable is changed. And so if the value, which is passed to the setter, And by the way, when you define a setter, it basically won't set the variable at all. So it allows you to manually define what happens when someone sets the variable to something. So if the open variable changed, then we are going to update the open variable, and then because we have to do that, if we define a setter, we have to manually set the new value. And then we'll call this update door function. So anytime it swaps from open to not open, we'll call the update door function. And then finally, I'm going to add this function to just make it easily callable from a signal to toggle the open variable. And remember, this negates the value of whatever's next to it. So if it's true, it'll be false. If false, it'll be true. Opens and closes the door. You can also use getters, which this will define exactly what the variable returns when you try to access it. And so in this case, I am just lying. This isn't really a variable. If you try to set it to something, it's just not really going to work. And it's always just going to return a random integer. So probably you will never see this example in the wild or in your own code. I don't think there would be a use case for this really that would be a good idea. But yeah, this is what getters are. Primarily this would be for like a computed value. Like if you had something like a variable that's like a proxy for something else. So you set a variable and it's like kind of acting as a proxy for a series of other variables, or a proxy for accessing like another object, and then it depends on some other series of variables. You can use it like this and kind of use variables to abstract your stuff in an interesting way. Might be some good use cases for it. But yeah, we're not doing any variable trolling today, so we're going to delete that, and we're going back to signals. And to make this door animate, we can just slot in this interactable component we already have. I'm just going to add a child node of an interactable component. And let me know if in the comments you saw that bug right there. I swear I just added it as a child of the animatable body 3D, but it became a child of the parent above it. Don't know what happened there. I think that happened twice while I was recording this actually. So yeah, I'm going to connect that interacted signal. And yeah, I'm simply just going to pick, just like we did before, click the toggle open method on that animatable body 3D. And you'll see it comes up with this little green signal icon in the script when we do that. And now we got this working door. So we have this door, we easily just slot in our interactable component. Shapecast is detecting it, similar to the button, and it all works. And now I'm realizing I probably want to activate this door with the button as well. So I'm going to add another signal for that. Pretty easy, just connect the interacted signal again from the button's interactable to the animatable body 3D's interactable again with the toggle open. So we got two signals on that toggle open, calling that function now. And now everything is working. We can open the door with the button, and we can click E on the door as well. If we try to press the button from behind the wall, it's not going to work because we got our shapecast, and that's hitting our wall. And we got pretty much everything working as we want it to. And thanks for watching. Hope this tutorial was useful to you. Hopefully it helped some newer Godot users, and hopefully gave you some good ideas for how to implement interactable components in your game. And hopefully you can see how this concept of the node child component pattern, where you just have like a small node with a script on it with the component name, and you can just use get node or null and check if it's a component of a specific type. And you can use that to just put components of any kind you want on objects. Maybe you would have some for like items or certain types of items or enemies or something like that. It's useful in a variety of places, and it's a good little pattern to know, and it's a pretty common one you're going to see in Godot code bases. And you could extend this concept of interactable items that you can press E on. Maybe you have some that you can pick up like into your inventory or something like that. And I'm sure you could think of a variety of use cases for your particular game, whatever you have in mind that you're making, that you could make into components, reusable little pieces of code to kind of put a trait or a type onto something, and have this reusable component type that you can use on multiple things. And that is the end of the video. I hope you enjoyed, and if you've been watching the series, we got a good amount of code for this character controller built up. Of course, the whole thing's on GitHub. If you ever want to download it or reference the code or do whatever you want with it, it's all in CC0 public domain license. So I hope you enjoyed the video, and I hope this helps somebody, and thank you for watching.